So we are good to go. So good morning, good afternoon, good evening, everyone, and welcome to our first workshop for the series of Build Smart on Kubernetes. To register and get the most out of this series, please register to this link that you will find at the top, which is crowdcast.io/e/bsok-bootcamp. You can find all of the details in this Crowdcast too. And let us talk to you a bit about the series itself. So this Build Smart on Kubernetes series is designed to help you get familiar with all the different concepts, from containerization to more technical aspects of microservices. So for today, we're going to focus more on containerizing and deploying a simple website. On the 8th of July, we have explore operators and simplifying application deployments. On the 13th, we have continuous deployment and integration using tectonic pipelines. And then lastly, we have integrating deep learning models into microservices application. So, at the end of this series, we're going to have, you can earn a badge for this after attending all of this series. So to earn your badge, you would need to attend 3 workshops out of the 4 and answer 75% of the questions correctly. So, before we jump in, let us introduce ourselves. So my name is Yusuf Al-Nimr, and I am joined by my colleague Mustafa Abdul Alim. We are developer advocates from IBM, and we are based in Egypt. So again, for today, we're going to be covering, how to containerize and deploy a simple website. So from the title, we're going to be covering why are we moving to containers, and what are microservices, and how do they play a major role in deploying applications. So to help you get started, first you would need to log in or sign up for your IBM Cloud account, and you would need this account to access the quiz at the end of the series. So which you will find at the second link here. Now, to earn your badge, your email must be the same as the one you're using for your Crowdcast and for your IBM Cloud account. So just to it's to help you track if you've attended at least 3 workshops out of 4, and accordingly if you answer all the questions correctly. So as you just mentioned, so here you're not going to be asked anything outside of what we're discussing. So all of the questions will be related to all of what we're discussing today and for the upcoming workshops. So don't feel intimidated from answering the questions. You may find some detail, some hidden details in the workshops accordingly, or in the presentations. So you might need to pay more attention for that. Lastly, we'll be sharing a survey link with you guys, so you can share your thoughts on the series in general, and what are you looking forward to in the future, and so on. So let us give you a bit of an orientation on Crowdcast. So to view more information about this event and the whole series, the bootcamp in general, you can find it at the top left here. So you can find that we have 4 sessions, and today is the first one. Now, to follow us and get notified about our upcoming events, you can just click on the follow button, green button here. And if you want to chat with everybody, just type something at the bottom right. And then if you want to answer polls or ask a question, we have these 2 sections here. So we have the Q&A, and we have the section for the polls. Now, lastly, for the workshop resources, just click on this green button, which is for create free IBM Cloud account. Now, this account, you will need this account for the hands-on workshop, and for, again, answering, just earning your badge for the bootcamp, to show us your skills and your knowledge and what you've learned from this bootcamp accordingly. So you will need, just access all of the workshop resources here as such. So, to navigate the workshops, just click on the schedule button here. Just click on more, and then select the workshop that you would like to access. So, again, to get the most out of this the series, please make sure to follow it and register, and attend all of them accordingly. So here you can find different workshops, and you can choose them as such. So before we jump into our workshop for today, let us give you a bit of a talk about call for code. So it's a competition that is held every year, and it's designed to address some of the major world challenges. So basically, we're focusing on different problems. So for this year, we're focusing on have zero hunger, sanitation, and green consumption. So the thing about Call for Code here is that you're focusing on building different skills in the hybrid cloud technologies, and enhancing your professional career. You're also looking to building a network. So if you're expanding your network, you can meet different people from all over the world, and you can share with them your thoughts or your solutions and so on. And also, if your solution here wins, so the idea here is that the winner for Call for Code gets $200,000 as a grand prize, and their solution gets implemented by the Linux Foundation. So you basically get support to deploy your application, your solution here. So to check out more about Call for Code, just go to developer.ibm.com/call-for-code. Now, let us jump to our agenda for today. So for today, we're going to be discussing, the difference between monolithic and microservices, what are containers, what is Docker, and then we're going to move to container orchestration. So, we've shared some of, in the polls here with you guys, if people are familiar with any container orchestration tools. So we're basically assuming, you might be familiar with it. Maybe you're not. This is okay. So you don't need to be intimidated, or if it's a new topic for you. So no worries about that. So we're going to be covering everything here to help you take your first steps. So let us get started. So usually we like to start with this analogy of the Great Pyramids. So how were the Great Pyramids built? So was it one piece that came out of the sky and then it just hit the ground, or was it built block by block over the years, and then it got its structure here accordingly? So the thing here is that the Great Pyramids were actually built piece by piece. Now, this is why over thousands of years the Great Pyramids did not collapse, or they're still resilient. The thing here is that if you take one piece of the pyramid, the whole pyramid is not going to collapse, and this is why the Great Pyramids are still resilient till today. So if assuming if it were one piece, maybe someone would throw a rock at it and then it would entirely collapse. This is not the case. So the idea here is that building it block by block is what's making the pyramids resilient. So how does that actually relate to our topic for today? So if you take if you look at the blocks as microservices, or a block, a single block, your application consists of multiple microservices. So here your microservices are the building blocks for your application. So let's say you have here, there's a microservice for logging in, there's a microservice for viewing posts, there's a microservice for posting comments, and so on. All of these constitute your application. So if you gather lots of microservices together, you get your application here. So the thing here is that again, if we go to the analogy of the pyramids, if one microservices crashes or gets taken down, your whole application is not going to be affected. This is why you see applications like Instagram or Facebook, and so on, not crashing, simply because there's one functionality that's not working properly, because they're basically based on the concept of microservices here. So let us take a more closer look here. So in monolithic architecture, it means that your entire application is bundled in one piece. So what this means here is that you have this single executable file, and it runs on a server. So you have the user interface, the backend, and the database all together, and they're on your server. In microservices, we have you have the user interface, and we have, for each functionality, a different microservice. Now, this guarantees that if one microservice crashes, the whole application is not affected. So some people could be liking posts, or exhausting one functionality more than the other. So the thing here is that you want to make sure that this microservice, gets the priority over the others, or, in a sense, that. So what happens here is that if all of these microservices can scale up based on demand. So if somebody is using one microservice over the other, so let's say people are logging in more than they're just writing comments or liking posts. So in this case, at least you guarantee that this microservice can scale up and down based on the load that it has. Okay. Also, if one microservice crashes, again, this doesn't affect your entire application. So if you have any questions, please write us in the Q&A section or in the chat, and Mustafa and I will be gladly getting back to you guys. So, in today's world, why are we adopting microservices? First off, we have maintainability. So, if we're talking again about monolithic applications, so the thing here is that if, let's say, we find a bug, or our application crashes in a monolithic architecture, what will happen here is that we're going to have to take down the entire application and then check for the logs of each component. So it could be the UI, it could be the backend or the database, and we're going to check the logs accordingly. Now, what's going to happen here is that if, let's say, we find a bug or there's an issue in the database, we're going to have to take down the entire application, fix our problem, and then push our application back again to our server. However, in microservices, we don't have to worry about doing that. We just take down that one microservice and check what's going on wrong with it, and then we just push it back again. So in that part, we have maintainability. So you don't have to, you don't need to take down your entire application to push changes or check out what's going on in your application. Secondly, we have independent timelines. So here you don't have to worry about relying on different microservices to start working on another microservice. So let's say we have A and then B. So they're independent of each other. So their functionality is they could be relying on each other in terms of communication. However, if in terms of development, you don't have to worry about finishing A to start B. You can start them independently, and then when it comes to integration, it's okay. That's a different topic. But here you're working on them independently. Third, we have faster agile iterations. So here you get to test out the microservice quickly, and you don't have to worry about going slow in the process. So here microservices take faster agile iterations. Also, they preach for software engineering principles. So the idea here is that software engineering always praises loosely coupled applications, or having things loosely coupled. So you don't want things to be heavily dependent on each other, because otherwise it'll be really hard to maintain an application. So microservices preach these principles as such. And then lastly, we have what is called cloud native. So if you're developing what is called a cloud native application, you would adopt microservices there. This is also a topic for a different workshop, but generally this is basically what has been going on lately. So how do we develop microservices? How do we get to separate our application into different functionalities and have them as microservices? We use what is called containerization. So what are containers? Containers are lighter and faster virtual machines. You can think of them as such. So what happens here is that we have, in a containerized application, this is usually what the architecture looks like. So we have our infrastructure, we have the operating system, and we have what is called Docker engine. We're going to get there in a minute in the next slide. And then on top of the Docker engine, we have our different applications. So these applications are all independent. They're separated from each other. So that's the best thing about containerized applications. Each application has its own access to its own memory and storage and so on. So, containers provide isolation and portability. Now, this is the best thing about it. So, let's say you want to take a Python application and have someone else use it. So you can just have it in a container instead of, taking the source code and having them deploy it. There could be specific requirements for your application. So you don't really need to worry about that in containers. However, if you're just taking the source code, you might need to set up the dependencies and all of that hassle locally on your machine. So in containers, containers are easily portable in that sense. Lastly, there's greater efficiency in containers. So as we just mentioned, you don't need to worry about working on fixing dependency problems, or having the right version of a certain programming language and all of that hassle. So this is why people go to containers. So let us talk about Docker itself. So how do we build our containers? So we've just mentioned that we have this Docker and we have our applications running on top of it. So Docker is the most popular container engine. Now, what does that mean? So in Docker, we have first we have what is called a Dockerfile. Now, Dockerfile is basically a setup contains a set of instructions that we use to build what is called a Docker image. So in this Dockerfile, we can specify what programming language are we using, if we want to set up certain directories and all that. If we want to get into Docker itself, it could be in a different talk. So we're not going to get into details into it today. But the thing here is that you can think of Dockerfile as a set of instructions that you use to build what is called a Docker image. Now, this Docker image is kind of like you can think of it as similar to how you run an operating system. So it's kind of the same concept here. So you have the programming language, the operating system that you would like to run in that container, and all these specifications in a Docker image. So next, we take that Docker image and we start running it. And then when we run that Docker image, we get the Docker container. Now, this container just contains that one application of yours, and it's up and running all there. So now there's a problem about Docker. So let's say we have all of these containers, but we don't know how to manage them. So we have no idea how to control the state or the status of the containers themselves. So in that sense, we need what is called a container orchestration. So how do you manage all of these containers? We use what is called Kubernetes. So Kubernetes, you can think of it as the Docker of a ship. So it's let us talk about Kubernetes here for a minute. So Kubernetes is basically an open source container orchestration tool for automating application deployment, scaling, and management. So basically, it automates the recovery of crashed or failed containers, the scaling of containers, load balancing, and rolling out updates. Now, this is what Docker doesn't do. So let's say we have millions of containers running on our Docker engine. However, hundreds of them are failing or crashing. Now, what happens here is that we have to take them down manually and then put them back up. However, in Kubernetes, we don't have to worry about doing that. So this is what is meant by container orchestration. So let us take a look at the architecture of Kubernetes. So first off, we have what is called a cluster. So a cluster is basically a set of machines. You can think also a cluster is called a node. So here we have the Kubernetes master, and we have 2 or more worker nodes or clusters here in general. The smallest unit in Kubernetes is called a pod. So a pod usually encapsulates a container. Usually it's one container per pod, but you can have multiple containers inside a pod. So each pod is given a unique IP address. So you can think here that pod number 1 contains container this container that has a Python application, and this container 2 has a Java application, and so on. So again, A pod encapsulates a container, and usually it's one container per pod, but it could be more. This is fine, depending on the use case. We also have what is called a kubelet. So the kubelet is what communicates with the Kubernetes master. So if in case there are issues running in the node, the kubelet is what communicates or relays the messages to the Kubernetes master. We also have the kube proxy. So the kube proxy is inside the worker nodes. Now, this is what handles the networking service. So basically, if you want to assign an IP address to each pod, this is the job of the kube proxy. We also have the etcd. So here we have, so this is inside the Kubernetes master. This is usually what stores, the cluster configurations and data. So, if you have the actual state, and the desired state. So let's say the state of the cluster is that, it's down, or there's problem going on with it. So, and the desired state is to have it running. So this is what is meant by the actual state and desired state. We also have what is called the scheduler. So this scheduler is what assigns pods to nodes. So this is usually based on load balancing. So the idea here is that you don't want to assign a pod that to a node that is overworked, or overloaded here. So in that sense, the scheduler is assigned with that task. We also have the controller manager. Lastly, the controller manager is responsible for taking actions and watching for the states of the system. So based on the information given from the etcd, the controller manager takes action accordingly. Now, to interact with Kubernetes, we have two different options, which are either the user interface or the command line interface, the kubectl, basically. All right. So if you have any questions, please let us know in the comments, or in the chat, or in the Q&A section. All right, so we're good to go. So now this brings us to our next talk for today. For today we're going to talk about OpenShift. So what is OpenShift itself? So Red Hat is an American multinational software company. And Red Hat is mostly known for their enterprise operating system, which is called the Red Hat Enterprise Linux, or RHEL. Their most eminent product is called OpenShift. So it's basically, you can think of it as an enterprise or a commercial Kubernetes. Now we're going to talk this about in a minute. So what Red Hat does here is that it operates on a professional open source business model, and it sells subscription-based customer support. So OpenShift is basically, it's a platform for deploying cloud-native microservices-based applications, and it could be hosted locally or on a public cloud, just like we're going to see today. So, what are the differences between OpenShift and Kubernetes? Now, OpenShift is supported by Red Hat, while Kubernetes is supported by the community itself. So, and if you want to get more professional support in that sense, OpenShift will be the right option for you. Otherwise, Kubernetes is good to go. OpenShift also provides a feature called source to image. So basically, you can take your source code, transform it into a Docker image, ready to be deployed on your cluster. Also, the OpenShift security policies are much stricter than those of Kubernetes. So you have security regarding the image registry, regarding the networking of the cluster in general, and so on. Also, OpenShift has a built-in Docker image registry. So this is one thing about it. So it's private. No one externally can access it. OpenShift also has its own CI/CD tools. So if you're looking more into building your applications through continuous integration, continuous deployment, or delivery, OpenShift would be right there for you. So it pretty much has all of these tools integrated within the clusters. Lastly, OpenShift is, it has a user-friendly interface, and it can be operated entirely from the UI. So let's say you're somebody who doesn't really want to deal with the hassle of working with a command line interface. Red Hat OpenShift is there for you too. So in case also you're not a developer and you don't want to get into the details or the hassle of where does this go into my application and so on, OpenShift would be the right option. So having that all said, we'll be moving on to the hands-on workshop. So again, if you have not signed up yet for your IBM Cloud account, please do. Also, to get to get the most out of the workshop for today, make sure you get your OpenShift cluster. So from this link, and the key to access the OpenShift cluster will be this. It's the OS lab. So I'll be handing it over to Mustafa if you would like to add anything. So Mustafa, you are good to go. Thank you.
Hello everyone, thank you very much, Yusuf. I would like to start by thanking Yusuf for the great presentation. And to start the hands-on part, the most important thing that every one of you should have an IBM Cloud account up and running, and also you should have your own cluster to be able to like replicate whatever I do. Today's application is pretty simple because as you see, it's an introductory level hands-on. However, it's going to be more advanced in the future, the webinars to come, the other webinars in our series. So I would like to start by asking everyone to please go ahead and create your IBM Cloud account, and then go ahead and claim your free cluster. I'm going just to give like everyone 2 minutes or something to make sure everyone has his IBM Cloud created, and then I'm going to then I'm going to show you how to claim your free cluster. So I'm just going to give everyone like 3 minutes, and then I'm going to get back and show you how to get your free cluster. And please, everyone, if you have succeeded to create your account, please let us know in the chat so that we know we have given you enough time to do so. And another thing to say that we have a green button at the bottom of your screen. If you click that, you will be redirected to a shared note with the link to create a free IBM Cloud account, and also the link to claim your cluster. I think we have had enough time for creating our account. So if you please, Yusuf, let me share my screen. Thank you. So hopefully all of you can see my screen. So let me open the shared note also to show it to you. So if you open the shared note, which is the green button, you can see to the bottom of your screen, you can see we have two links here. The first one is to sign up for a free IBM Cloud. If you go to this link, you will be asked to enter some basic information about like your name and your email, the mail you want to register with, and then you go ahead and press next, and then you verify the creation of your account or the registration from your email, and then you can get back and you should be seeing this interface, which is IBM main interface. Now, the second thing you need to do is to get your OpenShift free cluster. That's what we are going to use today. So to do so, you have to go to the URL. So just go to the URL, and then you will be asked for a lab key, and the lab key is also shared here, which is OS lab. So you'll have to enter OS lab, and then you would have to enter the mail you have created your account with, or the mail you have for your IBM ID, which is simply the mail you have registered with for IBM Cloud account, and then you would have to agree to the terms and then submit. After doing that, you should receive an invitation mail to the mail you have registered with, asking you to accept the invitation to be joined in our workshop account, where you will you will see that you will have an OpenShift cluster created for you. So if you have done so, have created your IBM Cloud account, which you have to do first before claiming your cluster, and then if you have gone to the URL and inserted the lab key and then your mail and accepted the invitation to join the workshop account, this is what you should be seeing. And another thing to note is that the clusters are first come, first serve. So if you're not successful to get your cluster, you don't have to worry, because in every webinar, in the upcoming webinar in our series, you will have the opportunity to have a free cluster, and you can always go back and do all the 4 labs. You can even, if you want, you can even go ahead and try and play with your cluster a bit. And if you didn't manage to get one cluster today, you can always get it in one of the upcoming webinars. So this should be the main interface of IBM Cloud. And if you created, or if you have claimed your cluster, you should also see that you have another account here called AdvoWork. If we choose this account, let me get back to show you the difference. So this is your main account, a simple account. If you go to the clusters, if you go to the OpenShift and then clusters, you will see you don't have any clusters. As you can see, we don't have any clusters here. However, if you claimed your account, or claimed your cluster, you should be seeing one cluster if you choose this account, which is AdvoWork, the workshop account for today. So as you can see, I have one cluster here called OC Bootcamp. As you can see, it's normal. It has 2 work account, and it has been created since today. So hopefully everyone was successful creating his account and claiming his OpenShift cluster. If you haven't, please let us know. This is the most important part of today's workshop. So please, if you have any problem, let me know in the chat section. Me and Joe will try to help you as soon as possible. So please let us know if someone is facing any difficulties, like creating his account or even claiming his OpenShift cluster. And always remember, you can have, or you can access those links all the time using the green button using the green button to the bottom of our screen. Okay, I would say that everyone is successful, and I'm going to go ahead. So what we're going to do today is that we are going to deploy our first application on OpenShift. And mainly it's the same process for different languages and different development runtimes. However, we are going to use a very simple application using Go language today. And actually, the first thing I want to do is to get you, or to give you the link. Let me get you the link for the GitHub repo, which contains all the files we'll be needing today. Let me also share that with you.
So I'll be pasting that in the chat, no problem.
Yes, sure. Thank you. Thank you, Yusuf. Sure. That to you. So here's the GitHub link, or the GitHub repo, having everything you will need for today's session. As you can see, we have something called Dockerfile, and Yusuf have explained previously what is a Dockerfile, and we also have something called main.go, which is the main file for today, the main file containing our code for today. And as you can see, you see the documentation and every step in the way and how to do it. So you have 2 options. You can just open any text, any text editor of your choice, or any programming platform of your choice, and then you can copy and paste every snippet of the code. And as you can see, I will walk you through the code we have in our main file, and then we can go ahead and deploy it. So as you can see, the first snippet here, or the first part in our file, which is main.go, is simply just importing some packages we are going to be using, which is net.http, which is used to create our server, and FMTP or FMT to it's like something like cout in C++, to print something to our terminal, and then we have the HTTP template to process our templates or our HTTP templates. And then we are going to create our main function. Inside this main function, we are going to create a variable, and this is the syntax to create a variable and using Go. So a column and then an equal sign. And then we are going to use something called, or method called template.must, which is going to handle if we have any errors. And then we are going to use a template.parse glob template slash star to get everything inside the template folder we have, which is simply the folder having all the templates or HTML files we have. If we go back, you can see we have in the template folder, we have our HTML file. As you can see, it's a very simple HTML file, only having some logo and showing the current time. Let's get back to our file. And the second thing we are going to do is that, as we all know, any HTML file or any website would have some static files that we need to use. In our case, it would be the CSS files. And to do so, we have also to create some handle to be able to point to these static files, the CSS files that we need for today. So we are going to use this code snippet, and here we are going to give it some reference, and this reference can be whatever you like as long as you stay consistent. And then we are going to use the http.file server to find all the file, or to parse all the file inside the static directory we have. And again, if you go back to the main folder, you will see that we have a static style sheet right here having the CSS and the image we'll be using for our website today. We get back, and then the last piece is using our HTTP.handle function, and we are going to pass two parameters to it. The first one is the pass we want to use, and then we are going to pass some function that takes a pointer and takes also a response writer, and then we are going to render our HTML page, and then we are going to just print some stuff to our terminal. So with that, we have explained every line or every piece of code we have inside our main file or main application. Now, let's get back to our OpenShift and see how can we create our application or deploy this application. So the first thing, we are going to use the web console to deploy our application, and it's very easy. And to do so, we have to start by getting to the OpenShift Web Console. To do so, you choose your cluster, and then from your cluster right here, you can go directly to OpenShift Web Console from here, which should open another link, which is OpenShift Web Console. Sorry, let me try that again. Okay. I think I have some problem with this cluster. It's okay, you don't have to worry about anything. So everyone, please make sure you can access your account and your cluster. In the meanwhile, I'm going to go ahead and open another cluster. Let's close this one. Yes, it's okay now. I think it just had to load. Again, still have some problem.
Yeah, I think the add-ons are still waiting to be downloaded.
The what?
The add-ons. So just check the. I think the
No,
cluster is now
I've
up.
tried it. It should be working. I think it's some.
I think now it's good to go. You can try again.
Yes, I think it should be.
No, there's an issue with the nodes.
Yeah, it's no problem. I think we can try another another cluster. Let me just see if I can access any other cluster for now. So please, everyone, we can use this time to make sure everyone has access to his account and OpenShift clusters. If you have any problem, please let us know in the chat section. Here's another cluster. So everyone should be seeing this interface after pressing to go to OpenShift Web Console. As you can see, here is our cluster main view, and now we have two views. We have the administrator view, and we have the developer view. Actually, we can go ahead and choose the developer view. It's much simpler and have or more focused on the developer view, which is where you can go to develop and deploy your application. And you can also go to the administrator view, which would have more options and everything about the project and to delete a project and stuff like this. However, we're going to use the developer choice for today. And to create an application or to deploy an application, you will have to choose add, and then you can just choose any simple application or any project and then create it. However, we can create a new project for today. I'm going to name it Golang X for Golang example, and then create it. And as you can see, you can create your application from different sources. So you can just choose a sample from different language, and then you can choose the language of your preference, and then you can choose to deploy it directly from a GitHub repo, and you can choose to deploy it from a container image or from a Docker file, from a YAML file or YAML configuration, from the catalog, a database or operator backed, or you can choose to deploy a Helm chart with different components of your application. So today we are going to use from a Dockerfile option. And what we have to provide here is only the GitHub repo URL, which has the application or our application. Let me grab that. Sorry, we don't need this anymore. So does anyone has any problem? Please let me or Joe know in the chat section, or you can follow for any reason. Again, here is a GitHub repo we need to use. We will need to use. So make sure you don't have any spaces before or after the URL, because it's going to give you some error. And then you don't have to change anything because it's a Docker file, and then you can just change the port if you want to change the port of the container. And then a general, which is simply you can specify the application name, and if you want to add some deployment or build configurations. However, we don't need to do that any of that for today's tutorial. And then we can go ahead and press create, and then we are going to be redirected to the topology view, where we can see our application as an icon here. If we open that or press on that, you can see that we have two processes. The first one would be the building, and then we are going to run our application. So it's now building. If you want to see the logs, you can just go ahead and view the logs and see what's happening right here. And as you can see, we are using a container. So it's simply downloading or getting every layer of our container, and it's pulling the image, as you can see. And get back to the topology. As you can see, it's still building, and we have a root here. If we try to open this root, it shouldn't give us anything. That's true, because it's still building. We have to wait for our building to be done and then our container to be up. We can see that we don't have any containers running for now. should be yes. As you can see, the build is now complete, and now we have a container running. As you can see, we have one pod running right here, and you can also view the logs for it. And you can see it says listening. Let me get back or open this one in another link, and then try to open the link another time. And as you can see, now we have the PNG file, and the current time in Egypt is 4:45. So that's it for deploying a Go application, or for any other language it would be a very similar process, or simply an identical process if we're going to deploy it using a Dockerfile. Now we have managed and deployed our application through the web console. Now we can try to deploy it through the CLI. For this part, or for the previous part, you only needed to have you only needed to have the IBM Cloud account and then your OpenShift cluster. For this part, you would need to have also the OC CLI. So if you don't have that and you want to try and deploy using the CLI, you should also have the CLI for OpenShift. First thing we will need to do is we are going to have to download our GitHub repo. So let me also share it again. Please, Joe, share it again in the chat section. Here is our GitHub repo, so you can just simply download it as a zip file. However, I'm going to clone it, so I'm going to copy this from here. Then I'm going to use git clone. So should have it right now. So if I cd golang, let's show you that we have it already. As you can see, we have it right here, golang. So let me go ahead, just also zoom in. And then cd golang. And simply what we need to do is to use the OC, and then maybe you can create a new project or directly deploy it to the default project. If you don't choose any project, it will directly deploy to the default project. However, we can create a new project for that. So let me start with, we have to log into our OC. So to do so, you can just type in OC login and then add your credentials, or you can just copy the login command from here. Token, and get this link, fix it here, and now we should be inside our OpenShift. As you can see, we have 67 projects, and we are using the project default right now. I'm going to create a new project. Let me name it OC, and then new project for a new project, and let me give it a name. Also Go EX for Go example. As you can see, we have it right now, and if you want to check it, it's already. You can check for your projects or from the CLI here. If we go to the administrator view, in the projects, we should see something called Go EX. As you can see, get back to our, and we are using it right now. Now we are going to deploy our application using the CLI. As you can see, we have a Dockerfile right here, and we have our application. So I'm going to go ahead and OC new app, and then I'm going to give it the directory of our application, which is the current directory. I'm going to just add dot, and I'm going to give it a name. So I'm going to give it a name, and I'm going to give it a name. Let's say Go EX2, and we will have to wait for our application to be deployed. As you can see, it's creating the resources. If we choose this project, let's get back to our developer view. And then in the topology of the Go EX application, we can see it's building right here. So we can wait for the building. And in the meanwhile, one thing about deploying an application through the CLI is that it doesn't automatically create a route for it, or it doesn't dynamically create a URL for it. So you have to do this, and to do so, you have to do something called expose, or you have to expose your service. So we have a service right here, and as you can see, if you see the difference, we don't have any roots right here. So to do so, we have to expose our application, and as you can see, it's also telling you how to do so. And if you want, you can just type it. We have also OC and then expose, and then SVC, sorry, for service, and then we're going to give it the name of the service, which is Go EX2, simply the name of our application. It should create a route for us. As you can see, we have a route now. However, if you want, you can go and get it from here. Here is our route. Okay. We try this link. Should be working. I think it's just taking some time, maybe still creating. Yes. As you can see, it's working now. So that's it. We have created or deployed our application using two types or two methods, using the OpenShift CLI, the developer view, and then the OpenShift CLI. And with that, we reach the end of our workshop or tutorial for today. And I will send it back to Joe, because I think he would want to share some important links with you. The floor is yours, Joe.
Yes. So thank you, Mustafa. Now let me just yeah. So I just want my screen to be at the top. So yeah, thank you.
I think
Okay, so let me
some people have some problem authentication to your cluster.
yeah,
So
we can. So okay, so we can see Rashma is able to access their cluster now. So that's good to go.
So Pedro, as I told you, you can just OC login and then give it the credentials, or you can copy the login command from the web interface of OpenShift. Okay. Again, please, if you have any problem, you can go ahead and go to the GitHub repo and follow the instructions, and we can answer if anyone has any other problem.
Yeah, so for those who are having issues with their clusters, so please send us an email if the issue still persists throughout the day, and we'd be more than glad to help you guys, resolve this issue. So just to give you guys, our final words for today. So just a recap of what we talked about, and what we did in the hands-on lab. So we talked about how did containers come to, and how did this concept come to, and how are microservices used in applications, what are the differences between monolithic and microservices applications or architectures, and then lastly, what are container orchestration tools. So we would like to share a link here with you guys. So just let us know what do you think, or if you want to just share your thoughts on what kind of talks you want to see in the future, or if you want to see more advanced topics in that regard. So you can just fill out this survey link. Or you can just scan this QR code. We're gonna share it in the chat here with you guys. So just some useful links here we'd like to share with you. So if you want to get started with the BSOK series, just go to ibm.biz/BSOK-series. And we'll also share with you the IBM developers. So if you want to explore different topics and technologies, or have different tutorials and different articles, you can go to developer.ibm.com. And lastly, you can check our meetup, which is meetup.com/IBM-CloudMia, to check all of our upcoming events and previous ones, and watch them all on demand. We're also now on Facebook, so follow us to see all of our upcoming events and past event recordings and much more. So we'll be sharing different series and all that all of that in that regard for on Facebook. So you can go to facebook.com/groups/IBM Developer MIA, and you'll find events, past event recordings, different discussions on different talks, and so on. So with that being said, thank you guys for joining us for today. We hope you found this to be really beneficial. For those who are still having issues with their clusters, please reach out to us. And here are our emails, so you can either contact me or Mustafa. And yeah, so thank you and have a great day.
Thank you, everyone. Have a great day.
So let us just share the link for the for the survey there for a minute. And if people have any
don't forget, you can always get a free cluster in the next webinars, and make sure you attend the next webinars. It's going to be more information. It's going to be more advanced, and you will definitely get to learn more, and you will get access also to free OpenShift clusters.
Yes.
Someone was asking, will we get the certification? As Joe has explained before, we have a badge for this series, and in order to claim this badge, you have to at least attend 3 of the 4 sessions, and there will be a quiz. You will have to register in the link Joe have shared in the first slide. You will have to register and then take the quiz after the 4 webinars, and then if you got like 75% of it right, you will get your badge.
Right. So let us share the link for the the quiz here, just so people can have an idea where to look. So yeah, so we've shared the link here for you guys. So make sure you attend at least 3 of our workshops, and yeah. So all of the answer, make sure you check out the workshops, because to help you answer these questions accordingly. So if you have any more, if you guys have any more issues or any questions, please let us know. So Pedro, I can see that you're saying the cluster is working for you, so that's good to hear. So I think we are good. So nobody has any more questions. All right. So it's been a pleasure joining you guys here, and